hobbies are becoming big business.
So I just bought a hot rod front end and a custom chopper rear end and designed a battery box to go in between, and that was it.
Gary Christopik has a dream.
Yeah, a lot of head scratching and a lot of experimenting and an awful lot of doing things 2 or 3 times.
And he spent the past year building it in an airport hangar. And like the airplanes that surround him, he wants this dream to fly.
That was in 2007. Since then, I've been converting cars from gas to electric for other people. I've continued to work on my design, and I'm ready to move ahead with it now. I call it the Easy EV because it's easy to manufacture and easy to assemble.
This is a simple CAD model of the first design, and this is the vehicle that I built from that model. I call it a battery box on wheels for obvious reasons. This frame is filled with 24 deep cycle lead-acid batteries. I built a roll cage with windshield frame and made a rear fender. I drove it for 3 years before starting on the new design. I also built a kit plane and learned a lot about aircraft construction and the kit plane industry. The fuselage is made from foam core fiberglass, also known as composite construction. I added a whole plane ballistic parachute, designed my own instrumentation, and used a Subaru car engine. I also built a hangar from a kit to do the final assembly.
The first car was made from steel, but my goal was to use advanced composites. This is a piece from a honeycomb fiberglass panel. They come in 4x8 sheets, like a sheet of plywood. I cut apart a small piece to show the honeycomb material inside.
I started a full-size mock-up by hand-cutting 4-foot by 8-foot sheets of blue foam insulation from the hardware store. I glued the pieces together for the main frame part that I call the center bulkhead. The brake, steering, and suspension for the 2 front wheels will bolt to this section. The foam is just a quick and cheap way to work out details of the rest of the frame. The CAD model is updated, and then the prototype frame will be cut from the honeycomb panels. This was done to look at the battery box interface to the center bulkhead. Body filler was used to smooth out the layers. This will be done with fiberglass or carbon fiber on the prototype. The structural attach points will have steel inserts inside solid fiberglass tubes. These panels will be cut by a CNC machine. This is a desktop CNC used to build scale models. Inexpensive foam board can be used to evaluate different designs. The car frame is the heart of this project, and the process used to build the frames is the key to using inexpensive machines to making quality, precision parts. These 2-dimensional parts are then stacked together to make complex 3-dimensional subassemblies. Since they are computer cut, they fit together precisely so no fixtures are required and each frame is identical. The frame is similar to the first prototype in that it serves as the battery box, allowing for a variety of battery pack sizes and types. This quarter-scale model shows the frame with a basic chassis kit that will result in a street-legal vehicle in most states. The next step will be to design a simple cage for an open-air vehicle. I hand-cut some pieces to show the basic idea. This would have a front trunk, windshield, roof, and fenders. Another option would be to use a full fiberglass body. This is the Freedom EV, designed by Jerry Dykes. He's a boat builder, and he already made the molds to build these bodies. We'll be working together to provide that as an option. I've partnered with other engineers, business owners, and EV enthusiasts to help out on this project. An open source community can continue to grow and offer other designs and support.
Thank you for visiting this campaign. I'll be adding more information and updates, so stop by again. I believe that driving electric is one of the most important things we can do for our economy, our environment, and our energy independence. So please pass this along so we can help everybody drive electric.